Our fourth lesson in the right triangle unit involves solving right triangles. For this lesson, you absolutely must have a calculator. All right, if you have a graphing calculator, a TI-84, then the first thing you have to do is change the mode. And we're going to set the mode to degrees. The mode button is directly to the right of the second key. On my calculator, the second key is blue. Press mode, arrow down, and you will see, for me, it's the third row. The first word is radian, and that's what's highlighted. The second word is degree. Arrow over to degree and press enter, so the degree is highlighted. Okay. Then press second mode to quit out of this function. If you don't put your mode in degrees, all of your answers will be wrong. That is very painful on tests and quizzes. You do not want that to happen to you. All right, so our essential question is, how do I solve right triangles? Well, first off, what does it mean to solve a right triangle? Solving a right triangle means find all the missing angles and sides. When you've done that, you have solved the right triangle. Okay, you can use trig to find the missing angles and sides, but your calculator must be in degree mode. Okay, when we clear calculators for the SOL, it goes back to radians. So that's the first thing you need to do when you sit down to the SOL, is put your calculator in degree mode. How do I find sine, cosine, and tangent of an angle measure? So we're going to use our calculator for this. And we're going to round to the nearest thousandth. Make sure you read on tests, quizzes, and the SOL and see what they want you to round to. Okay, so sine is 2 keys above the 7. So you press sine, 48, enter. 0.743. Watch your rounding rules, and please always put a 0 in front of the decimal point. Okay, I don't want any naked decimals running around there. There needs to be a value on each side. Cosine is 2 keys above the 8. So cosine 67, 0.391. Again, watch your rounding. Tangent, 2 keys above the 9, 12, 0.213. It's that easy. If you get these problems wrong, it's usually because you round incorrectly. Please be careful. So how do I find the angle measure if I know the value of sine, cosine, or tangent? So we're going to use the inverse trig functions on our calculator, and for this I'm going to ask you to round to the nearest degree. Okay, so we're going to find the measure of the angle. Sine of angle A equals 0.6428. So what I want to use is inverse sine, which is written on your calculator directly above the sine button. So to get there, you're going to have to press second sine 0.6428. And this is approximately 40 degrees. Okay, to find the measure of angle B, we're going to use inverse cosine. So again, second cosine, 0.5592, and this is approximately 56 degrees. To find the measure of angle C, we will use inverse tangent. So second tangent, and this one is approximately 85 degrees. So how do I find missing sides using trig ratios? Well, we need to identify the relationship the sides have with the angles. So opposite, adjacent, hypotenuse. And then we have to ask ourselves, what trig ratio uses these relationships? Don't forget your mnemonic. So, ka, toa. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So if I'm given the information adjacent over hypotenuse, which trig ratio do I use? Cosine. If I'm given the information opposite over adjacent, which trig ratio am I going to use? Tangent. If I'm given the information opposite over hypotenuse, which trig ratio am I going to use? Sine. Okay, so we're going to use the trig ratio and the angle measure to set up an algebraic equation. Then you solve. The algebra should be easy peasy at this point. Let's try one. All right, I have 28-degree angle. So x is my opposite, and in this case, 19 is my hypotenuse. What trig ratio uses opposite over hypotenuse? And that would be sine. So sine is opposite over hypotenuse. That means the sine of 28 degrees equals my opposite, which is x, over my hypotenuse, which is 19. Now, I need to isolate the variable. I need to get x all by itself. So the opposite of dividing by 19 is multiplying both sides by 19. So x equals 19 times the sine of 28 degrees. Literally, 19 times sine 28, enter, and our answer is approximately 8.9199. So 9 makes me go up. This becomes a 10. 8.920. Watch your rounding. Okay, 41 degrees. This side is opposite. Hypotenuse doesn't have anything. This is the adjacent side. So what trig ratio uses opposite and adjacent? That would be tangent, TOA. So tangent equals opposite over adjacent. That means the tangent of 41 degrees equals x over 32. Again, I need to solve my one-step algebraic equation. Multiply both sides by 32. And x equals 32 times tangent of 41 degrees. 32 times tangent, 41. And you have 27.817. All right, next up, I have a 21-degree angle here. Let me see. Here's my opposite. Here's my hypotenuse. And here's my adjacent. What trig ratio uses adjacent over hypotenuse? Cosine. Cosine is adjacent over hypotenuse. So the cosine of 21 degrees equals x over 26. We're ready to solve the one-step equation by multiplying both sides by 26. X equals 26 times the cosine of 21 degrees, which is approximately 24.273. See, I meant it when I said easy peasy for the equation. So we now know how to solve for all of the sides in a right triangle. I could use this approximated value and the Pythagorean theorem to find the opposite side if I had to. Let's talk about how to find angles at this point. So we are going to start off by identifying the relationships the sides have with the angles, opposite, adjacent, or hypotenuse. And then we're going to ask, what trig ratio uses these relationships? We're going to remember SOHCAHTOA, because it all comes back to the relationship that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Then we're going to use the trig ratio and the angle measure to set up an equation. The problem is this time around we are solving for the angle measure. So we are going to use an inverse trig function to solve. Let's look at this. I am interested in angle x. This would be opposite, this side is adjacent, and this is my hypotenuse. So which trig function uses adjacent and hypotenuse? SOHCAHTOA. Bingo. Adjacent and hypotenuse is cosine. So cosine is adjacent over hypotenuse. That means the cosine of x will equal 8 over 11. Now, we learned earlier in these notes to find the angle measure, we need to use inverse of the trig function. So x will be the inverse of cosine 8/11. So second cosine on my calculator, 8 divided by 11, and x is approximately 43 degrees. Oh, I asked you to round to the nearest thousandth. I need to read. So 43.342 degrees. Okay, so SOHCAHTOA. This is my angle x, so I've got opposite, adjacent. I'm not using the hypotenuse. Which one trig ratio uses opposite over adjacent? Tangent. Tangent equals opposite over adjacent. So for this problem, the tangent of x equals 20 over 37. So x will be the inverse tangent, 20/37. Second tangent, 20 divided by 37, 28.393 degrees. Next one. SOHCAHTOA. I have opposite, and I have hypotenuse. So what uses opposite and hypotenuse? Sine. Sine is the opposite over the hypotenuse. So I'm going to find the sine of x is 15 over 24. Since I'm finding the angle measure, I use inverse sine. 15/24, which is approximately, ooh, that's a horrible approximately symbol. Let's try that again. Okay, second sine, 15 divided by 24, 38.682 degrees. That's it. Take a couple of minutes to write a summary of the important information from this lesson.